In lesson 5.5, we're looking at writing equations in point-slope form. And in part A, we looked at how to write an equation just in point-slope form. And now in this lesson, we're going to look at different forms, which are slope-intercept and standard form. If you don't have this summary in your notes, this would be a good place to put it. Slope-intercept form, we write the equation y equals mx plus b, where m is the slope and b is the y-intercept. Point-slope form, y minus y sub 1, the y part of our point, equals m, the slope, times x minus x sub 1, the x part of our point given. Standard form, we've had for a while now, ax plus by equals c, where a and b are not both 0, a is positive, and their greatest common factor of a, b, and c is 1. In example 4, we're starting off with an equation in point-slope form, and they want us to change it to slope-intercept form. Slope-intercept form is fine with having fractions. Actually, we like to see fractions there because then it's easy to see the rise of a run. So we can just distribute that 4/3. So y minus 5 equals 4/3 x. And happens to be that 4/3 times a third, those threes would cancel out, so we'd have just minus 4. And then all I have to do is add 5 to both sides. So I have y equals 4/3 x plus 1. That would make it easy to graph. My line has a y-intercept of 1, and it's going up 4 over 3 to get to the next point. For example 5, we have a figure graphed out, and it shows trapezoid ABCD with bases AB and CD. So the bases are parallel sides in a trapezoid. Write the point-slope form, the lines containing the bases of the trapezoid. Well, it happens to be that both these bases are conveniently horizontal, so the slope is going to be 0. So that makes our problem very easy. And it doesn't matter which point we pick, I'm just going to pick A. So when we plug in y minus the y part of my point is 3 equals the slope we said was 0 times x minus the x part of my point is -2, so minus -2 is 2. But when we multiply anything by 0, we get 0. If we started off with b instead, we would have had y minus 3, the y part of my point there, equals m was 0 times x minus the x part of my point is 4. So I get the same exact answer either way. So working on our other line, if we do y minus -2 is the same as y plus 2 equals, our slope is still 0 times x minus the x part of my point is 6. So once again, I'm going to get y plus 2 equals 0 times anything is 0. And if we wanted to, we could do the same thing with d, and it's going to be the same. So y minus the y part of my point is again -2, so plus 2 equals m is 0 again times x minus the x part of my point is 1 that time. So we still get the same exact equation. Now obviously when you're doing these problems you won't do them twice, but I was trying to make a point. So in your notes just write down one way. They'll also give us equations in standard form and ask us to change them to slope-intercept form. So I need to solve for y to do that. So I need to subtract 3x from both sides of my equation. So 2y equals 6 minus 3x, and divide both sides by 2. So y equals 3 minus 3/2 x. Or if we wanted to put it in the right order, it'd be y equals -3/2 x plus 3, which again is handy for graphing. If I needed to graph this line, I know it has a y-intercept at 3, and it's going down 3 and over 2 for our slope. So then I could graph the line. Very useful form, slope-intercept form.